In chapter 4, we talked about discrete probability distributions. Here in chapter 5, we are going to talk about continuous random variables and continuous probability distributions. So this is what we looked at in chapter 4. Your distribution, we had discrete values here like 0, 1, 2, 3, etc. And then the probability distribution was a histogram, a bar graph. However, here, in continuous variables, we've got a continuous curve here. So on the x-axis, we've got our data values, and then on the y-axis, we've got the probability of those data values. So for any specific data value, so for example, say that this was the value 3. If I want the probability of 3, I go up to the graph and over to the y-axis, and that value is the probability of the random variable taking on the value 3. So that's what this graph is telling us. Some notes here. This is a continuous probability distribution. In fact, this is a specific one. This is a bell-shaped distribution, which we'll talk a little bit more about in just a second here. So some notes here. One, your probability function p or f of x is a smooth curve. So there's no corners on the graph. There's no places where this function is not differentiable. And then 2, area under the graph. So area under f of x corresponds to probability that x is in a range of values. So area under the graph corresponds, I'll do double arrow, to probability. That x is in a range. So at the center of the distribution, we have the mean, and for example, say that this mean was equal to 10. And then let's see here, we've got 3 down here, so 5 would be about right there, and let's say 8 is about right here. So if I look at the area between 5 and 8, so this area in here, let's go ahead and put some color in there. So that area right there, that yellow area, that corresponds to a probability. This corresponds to the probability that our random variable x is between 5 and 8. So 5 less than x less than 8. So whatever that area is, that corresponds to this probability, which also corresponds to a proportion of the data, because remember, probabilities are just relative frequency. So here, let's look a little bit more specifically here at an example. So we have a bell-shaped distribution curve here, so a probability distribution. And the probability that x is between a and b for two numbers a and b is actually the same as the probability that x is greater than or equal a and less than or equal b. So since probability is area, it doesn't matter whether or not we include the area above one number, since that area is 0. So the probability that x is between a and b corresponds here to the area under p of x between a and b. So that's the general pattern. So let's say that our a is maybe right here. And let's say we've got a b up here. And let's go ahead and dump some color. So that yellow area corresponds to the probability that a is less than x is less than b. So probabilities or proportions correspond to areas.